Unit 6, Section 2 notes. This is rational exponents. So this first section we want to rewrite radicals in a different form. Notice I have some with an exponent that's a fraction. I have some that is not. It's just in a radical of some sort with different index. Alright, so the only notes you need for here we kind of went over yesterday. So I'm going to have, let me do some colors here. So I'm going to have my index and then my radical symbol, and then whatever my a, my x, my y, my 2, 17, whatever number is there, and then my exponent. Okay? That's what, if I start with that, I'm going to convert that to an a. And then you need parentheses if it's like a number with a letter, so like 2x or 15y or 7m. So if I have two things, or even like jk or mn, xyz, if I have more than one, I want to use parentheses, and then I just put my exponent outside, and then divided by my index. So that's where the fraction comes from. And then of course if I have the one on the right, I can go to the left. Same thing. I guess the only thing I would change, sorry, is parentheses again if it's more than one thing. So if it's like a 2 or 21x squared, I would want 21x in parentheses with the square. Now you can always use parentheses and you'll never go wrong. It's not incorrect to have parentheses when you don't need them. It's just that you don't need them all the time. So let's look at this one. So I have, if we wanted to label these, I have a, oh wow, no. I have a here. Here's my exponent on top. I'm sorry, here's my index on the bottom. Okay, and then there's a. So if I look at my notes, right, my a, I have the thing, the one on the right, so I have a number that's a, and then my fraction is e over n. So I want to go to the left. So as I write this, I'm going to write my number, 34. Now again, you can put parentheses, you don't need to, because it's just one number, it's just a 34 and that's it. But it doesn't hurt, it won't be wrong if you have parentheses. Okay, and then I'm going to write my exponent out here. And then my index, so I have a root. My index is 2. So again, I don't have to write a 2 here because it's square. It won't be wrong if you do. So you can leave it like that, or you can put the 2 there. Either way is fine, and that would be my answer. That's all I'm doing here is rewriting. I'm not solving, I'm not doing anything else. Okay? So you can write it like that, or a lot of people for this problem, because it's just a square root and a 1, you don't need the exponent, you could just write square root of 34. That would be the exact same answer. I would count both of them, that's fine. So that would be a very rare case where you don't need parentheses and you don't need an exponent and you don't need an index, because just the way it is, that's just how you write it, you don't need it. But on the rest of these, they are a little more specific. So like this one, I have a in parentheses, my e, my exponent, is on top, and my index is on bottom. So as I write this, I'm going to write 3x, and because again I have a 3 and an x together, I want parentheses. It should kind of help you that it's already in parentheses, so if it starts in parentheses, you're going to keep them. You're never going to get rid of parentheses, I will say that. So if it ever has them, you want to keep them. Okay, my index, or my exponent is 4, so I can write that here. And then my index is 3, so I will have a cube root. Now there is one other way you can write this. Another way you can write this, notice how my exponent is under the radical. You can also write like cube root of 3x like this, And then if you do parentheses over the whole thing with the exponent, that is also okay. Either way is fine. I don't mind either way, but I would recommend to pick one way and stick with that, because again, consistency equals, it just makes it easier. So the more consistent you are with how you do things and how you write things, the easier it will get. If you're always changing back and forth, then you might confuse yourself and might make mistakes, and we don't want that. So pick one of these ways and leave it alone. Like, don't change it back and forth. I'm always going to stick with the first way because that's how I've always done it. Again, you can do either one, it's fine. Alright, so now we're going to go the other way. So on here, notice I have my A is 5x. My index is 2 because it's not there. And my exponent, because I don't have one, my exponent would be 1, right? Because remember, if you don't have an exponent, it's always 1. So the way I would write this is my A would be 5x. And because it's 5 and an x, it's two things, I have to have parentheses. Then my exponent is 1, and my index is 2. And that would be our answer. Now, it's important because, again, it's 5x, it's two things, it has to be in parentheses. Like, if, just for example, don't write this down. If I write 5x to the 1/2, that would be wrong, because without parentheses, that 1/2 only applies to x, not 5. Because I need it to apply to both, or all of it, that has to be in parentheses. Okay, so it's important to know that, and again, you can always do parentheses and you'll never be wrong. So if you want to put parentheses on everything, go for it. Alright, and the last one on here for, let's see, I have A is 15x, my index is 4, and my exponent is 7. So I would write 15x first, and I put parentheses because I have to. My exponent goes on top, so 7, and then divided by index of 4. And again, we're not trying to reduce anything, we're not trying to solve for anything, we're just trying to rewrite, just to kind of get in that habit, because you're going to need to for a lot of things. It'll help later on. So yeah, there's 1 through 4 of just rewriting radicals. So whichever way you're going, you know how to do it. Again, practicing is the only way to get better, so I would recommend doing that. And the last thing for today, the reason we learned how to do that and practiced, is you're going to need it now. So we want to simplify radicals using rational exponents. In other terms, I want to combine all my letters using fraction exponents. So like the first one already has the fraction exponents, but if you see on 6 and 7, it does not. So that's where I need to be able to convert very easily. So let's do this. Actually, real quick on the notes, just the only thing you need for notes on here is I would rewrite everything. So rewrite all radicals or roots, however you want to write that. Let's just say fraction exponents. I would say rational, but fraction is just easier, so fraction exponents. That's the first thing you want to do. Okay, so I rewrite all radicals with fraction exponents. Then I want to or not change, sorry, let's do make all denominators the same. Remember, denominator is the bottom part of the fraction, so if you need to write that instead, that's fine. So make all denominators the same. And then I'm only going to have two options for these kinds of problems, just of how they are. If I multiply my two letters, multiply is adding exponents, and then of course if I divide, I would be subtracting exponents. So multiply is adding exponents. Subtracting is, or no, I'm sorry, not, see, I'm getting ahead of myself. My fault. Dividing is subtracting exponents. So if I have a problem where I multiply my letters, then I will add my exponents, my fractions, and if I'm dividing my letters, then I will subtract them. So this is the order that you'll go in, and I guess the last one would be, well, if it wouldn't freeze on me. There we go. Last step is simplify. Always simplify. Okay, so we'll just add that on there. So I want to rewrite everything with fraction exponents. I want to make all my denominators the same. If they are the same, great, that skips a step. Then if I multiply, I add my exponents. If I divide, I subtract them. And then my last step would be to simplify, if I can. So let's look at the first one, number 5. Notice I already have exponents that are fractions, so I don't have to do that. My denominators are already the same, so I don't have to do that. So now I gotta look, am I multiplying or dividing? Well, the little dot is multiply, right? Of course, if it was divided, it'd be a fraction, like in number 7. So I'm gonna go ahead and rewrite this. I'll do A, and I'm going, since I'm multiplying, I'm gonna do 4/3 plus 2/3. So I'm adding my exponents. That gives me A. And remember, you just add the top two numbers, the bottom stays the same. So 4 plus 2 is 6/3. So I added, right? I have one letter now with one exponent, that's great. Now I simplify. 6 divided by 3 simplifies to 2. So my answer is A squared, and that's it. Of course, if I had something else that didn't divide, I would do what we did on the last lesson, where you split it up into two numbers and then you simplify one and just change the other to a radical, which we will have to do on the rest of these, so no biggie, right? Alright, so on this one, number 6. First thing, so these don't have the fraction exponents, so I want to do that first. So this one, first one, I want to write x, and remember you do exponent over index. So 2/3 times x, and then you do exponent, well, if it'll work. No? Okay. Exponent over index. Remember, no index is index of 2. So I rewrote them as exponents. Now I want to make the denominators the same because they are not. How do I do that? Well, if I have a 3 and a 2, what's the first number that they both have in common? You know, if I go by multiples of 3, I would have 3, 6, 9, 12, 15. If I go up by multiples of 2, I have 2, 4, 6, 8, 10. So which is the first number they have in common? 6, right? So that's what I want to multiply both of those to equal 6. So like on this one, the 3, since my denominator is 3, I want to multiply by 2/2. That'll change the denominator to 6. On the 5/2, I want to multiply by 3/3, because that'll make the denominator 6. So oftentimes, you will end up multiplying the denominators by each other. That's not always true. But if you ever have 2 and 3, you just multiply them by the opposite. Okay, so let's do that. So now I'm going to have x. So I do 2 times 2 and 2 times 3. So 2 times 2 on top is 4, and then 2 times 3 on bottom is 6. Then do the same thing. 3 times 5 and 3 times 2. 3 times 5 is 15. 3 times 2 is 6. Now, my denominators are the same, and since I am multiplying right here in the middle, I'm going to add. So I have x to the 4/6 plus 15/6. That gives me x to the 19/6. Okay, I can't divide 19 by 6, which is fine, so I'm going to split this up. So 19, I can do 18 divided by 6, and 1 divided by 6. Okay. If I'm going a little too fast, try it, maybe, rewind and go back and just rewatch it again. Maybe that'll help. Or if you need to, go back and look at yesterday's notes, because this is exactly, see, now we're just doing what we did yesterday. By splitting up the 19 into 18 and 1, we did that yesterday. So if you watched the last lesson, go back and rewatch it if you need to. So this first one, 18 over 6 reduces to 3. And then this 1 over 6 I can't reduce, so remember, my index is the bottom number, and my exponent is the top. Which I don't need that 1 there if you don't want to, that's fine. You can leave it, it's still right. Yeah, I'm not going to count it wrong. So that's how you do that one. So the first one was definitely a lot easier. We didn't have to convert, we didn't have to rewrite, we didn't have to change the denominators, and it simplified very easily to 2. This one's going to be a lot more common and probably more of what you see, especially on the homeworks and stuff like that. You're going to have more steps like this. So just be prepared. Now, of course, this included every possible thing. I did that on purpose. That way, at least you have in the notes every step that you could see. Now, you may not see all of them, which is fine, but that would be the most that you'll do. Now, let's look at 7, though. 7 is numbers. We treat numbers the same as letters when we do these problems. So, and I did this on purpose. So look at the top number is 40. That's the same thing as having x, right? Notice there's no radical and there's no exponent. So because I don't have a radical, I don't have an exponent, I would just simply write it, because I do want a fraction, it'd be 1 over 1, right? Because 1 over 1 is just 1, and that would be 40. So if you ever see a letter or a number with no radical, no exponent, that's exactly what you put. Okay? It'd be just whatever the exponent is over 1, if you have that. Now, divided by, I'm going to rewrite this one, so 40, and again, no exponent is 1, and my index is 3. Okay, notice, these denominators are not the same, so I have to make them the same. So I can multiply this top one by 3 over 3. That would make the denominator 3, right? Which is already what the second one is. Therefore, I don't have to multiply the second one at all. So look, I would have 40. So I do 3 times 1, 3 times 1 would give me 3 over 3 divided by 40, 1 over 3. Okay? So I rewrote them with exponents as the fraction exponents. I made them the same denominator. Now, I'm dividing on this one, so I subtract my fractions. So let's do that. Move down here, so I'm going to have 40, and I have the top fraction minus the bottom fraction. That's all I do. Okay? 40, so 3 minus 1 is 2, so I have 40 to the 2/3. Okay? Alright, so if I keep going, that doesn't divide, so I'm just going to do index of 3, and it'll be 40 squared. Oh my goodness. This was 0. Alright. Now here's the problem with this one, and I say problem, not really. Because it's a number, I can actually keep going. So, like on the last one we had x, can't do anything with x. But if I have a number, I can do more with this, right? So what is 40 squared? Well, 40 squared, if you need, real quick, that'd be 2 zeros, and 4 times 4 is 1600. Awesome. Okay, so I'm going to have to split this up. So I actually have cube root of 1600. You might be thinking, oh great, that's a large number. No problem, that's why I'm doing this one in the notes with you. Okay, so if we split this one up, let's do, we just had 40 and 40, right? Okay, so 40 and 40. Those both split up. You'd have 4 and 10, 4 and 10. So remember, we canceled those out. All right. So I can split up 4 into 2 and 2. I can split up 10 into 2 and 5. And 4, same thing. 4 is 2 and 2. 10 is 2 and 5. So see how that didn't really take that long? So that's not bad, right? Now, because my index is 3, right, my index is 3, I'm looking for groups of 3. So notice I have a group of 3 2s and another group of 3 2s, and I have this 5 and this 5 that are just stuck left over by themselves. No big deal. Alright, so remember, for every group of 2, I put one of those out there. So I have 1, 2 2s, because I have 2 groups. And then I have 2 5s. So remember, my index is 3, and I would do first number times second number. So if you have more than one number, you always multiply. So for my final answer on this one, I do 2 times 2 is 4, cube root 5 times 5 is 25. That would be my final answer. Now again, the notes, I try to include as many steps as you would possibly see in anything. So that's why it seems like it's a lot. Most of the homework you won't have this much, but occasionally you will have some kind of mix of these, which is why I have them in here. That way, at least in the notes, you have everything to look back on to help you. So if you don't see some of this stuff, if it doesn't show up on a homework problem when you're practicing, then good, you don't have to worry about it. But if it does show up, you have this to look at to reference. So please do the homework, please practice, because you do have, of course, quizzes and tests coming up you got to be prepared for. So if you have any questions, let me know.